All right, we're going to look at dot products. All right, so a dot product allows you to find the angle between two lines or the components of a force parallel and perpendicular to a line. So find the angle between two lines or the components of a force parallel and perpendicular to a line. So, sorry. Okay, so if you had vector A and you dot it with vector B, you would get the magnitude of A times the magnitude of B times cosine of theta, where theta is the angle between the two vectors. And theta is less than or equal to 180 degrees and greater than or equal to 0 degrees. So when you dot two vectors, you're getting a scalar. So that's really important. The product of a dot product is a scalar. Star this. Very important. Okay, so let's talk about the law of operations with dot products. So you got your commutative law. So that's that A dot B is the same as B dot A. And your associative law, if a scalar is multiplied by your dot product of A dot B, that's the same as a scalar multiplied by just A dotted with B. And then there's your distributive law. So if you had A dot B plus D, that's the same as A dot B plus A dot D. So if you had two vectors, let's just say they're the I vector, right? So only in the x direction. So I dot I. So I is a unit vector, so the magnitude's going to be 1. So is the magnitude for both of them, so 1 times 1 times cosine of 0, right? Because there is 0 degrees in between I and I. So the dot product of I dot I is going to be equal to 1. Now what if you did I dot J? Same thing, the magnitude is going to be 1 for each, and it's going to be cosine of 90. Because there's 90 degrees between the I-axis and between the unit vector I and the unit vector J. And cosine of 90 is equal to 0. Now if you had I dot K, 1, 1, and again, it's 90 degrees between I and K. So that's also going to be equal to 0. So let's look at this in Cartesian vectors, or Cartesian form. So if you had A dot B equal to AXI plus AYJ plus AZK dot BXI plus BYJ plus BZK. Right, and you multiply all the terms together, you would get IX, BX, I dot I, and then AX, BY, I dot J, AX, BZ, I dot K, plus AY, BX, J dot I, plus AY, BY, J dot J, plus AY, BZ, J dot K, plus AZ, BX, K dot I, plus AZ, BY, K dot J, finally AZ, BZ, K dot K. Alright, and now if you look at this equation, and you also look at this, right? I dot I is 1. Same would be for J dot J, because that's the only thing where cosine of 0. Every other combination, besides two vectors that are exactly the same, I dot I, J dot J, and K dot K, is 0. So, I dot I is going to be 1. I dot J is 0, so that goes away. I dot K, that's also 0. J dot I, 0. J dot J, it's 1, so it stays. J dot K, 0. K dot I, also 0. K dot J, 0. And then K dot K. So this simplifies down to I. A dot B is equal to AX, BX, and so I dot I is 1, so it goes away, plus AY, BY, plus AZ, BZ. So that's a simplified way to write it. Alright, so another way to find your theta, the angle formed between two vectors or intersecting lines, theta is equal to cosine of -1 vector A dot vector B divided by the magnitude of AB, where theta is in between 0 and 180 degrees. Alright, so now let's look at that, the part of the dot product where the components of a vector into their parallel or and perpendicular lines. So if we had an axis A, we had vector A, we could have A, so 90 degrees, you could have A perpendicular. So this is A parallel to A and A perpendicular to the axis A, and this would be theta. So let's apply that. Okay. So we're looking for the magnitude of AA going to be equal to A times cosine of theta, or A dot UA, where UA is the direction of the axis A. All right, and then if we're looking for vector AA, is going to be AA, the magnitude, dot with the direction. And then our vector A is equal to the vector AA plus A perpendicular. And that's basically what we've been doing in all of these, where you're basically putting A into its x and y components. Sorry, that's a little blurry. There you go. Now if we're looking at the perpendicular component, we can find that it is the vector A minus the vector AA, such that the magnitude of the perpendicular component is equal to A sine theta. Or it can also be written as the square root of A squared minus AA squared. So this just shows some of the varying ways that we can use dot products to look at that angle theta, or put the components into its parallel and perpendicular direction. All right, examples to follow.